We will discuss about the Sun, why study Sun, phase weather, about Aditya L1, major science objectives, Aditya L1 science payloads, why study Sun from space. Is Aditya L1 a complete mission to study the Sun? The Sun. Our Sun is the nearest star and the largest object in the solar system. The estimated age of the Sun is about 4.5 billion years. It is a hot glowing ball of hydrogen and helium gases. The distance to the Sun from the Earth is about 150 million kilometers and is the source of energy for our solar system. Without the solar system energy, the life on Earth, as we know, cannot exist. The gravity of Sun holds all the objects of solar system together. At the central region of Sun, known as core, the temperature can reach as high as 15 million degrees Celsius. At this temperature, a process called nuclear fusion takes place in the core, which powers the Sun. The visible surface of Sun is known as photosphere, is relatively cool and has temperature of about 5500 degrees Celsius. Why study Sun? The Sun is the nearest star and therefore can be studied in much more details as compared to the other stars. By studying the Sun, we can learn much more about stars in our Milky Way as well as about stars in various other galaxies. The Sun is a very dynamic star that extends much beyond what we see. It shows several eruptive phenomena and releases immense amount of energy in the solar system. If such explosive solar phenomena is directed towards the Earth, it could cause various types of disturbances in the near Earth space environment. If an astronaut is directly exposed to such explosive phenomena, she would in danger. The various thermal and magnetic phenomena on the Sun are of extreme nature. Thus, the Sun also provides a good natural laboratory to understand those phenomena which cannot be directly studied in the lab. The space weather. The Sun constantly influences the Earth with radiation, heat, and constant flow of particles and magnetic fields. The constant flow of particles from the Sun is known as solar wind and are mostly composed of high-energy protons. The solar wind fills nearly all the space of the known solar system. Along with the solar wind, the solar magnetic field also fill the solar system. The solar wind, along with other explosive eruptive solar events like coronal mass ejection (CME), affects the nature of space. During such events, the nature of magnetic field and charged particle environment near to the planet charge. In case of Earth, the interaction of Earth magnetic field with the field carried by CME can trigger a magnet disturbance near Earth. Such events can affect the functioning of space assets. The space weather refers to changing environmental conditions in space in the vicinity of Earth and other planets. We use more and more technology in space as understanding space weather is very important. Also, understanding near Earth space weather sheds light on the behavior of space weather or other planets. About Aditya L1. Aditya L1 is the first space-based observatory class Indian solar mass mission to study the Sun. The spacecraft is planned to be placed in a hollow orbit around the Lagrangian point L1 of the Sun-Earth system, which is about 1 million kilometers from the Earth. Satellite is placed in the hollow orbit around the L1 points has the major disadvantage of continuously viewing the Sun without any occultation eclipse. This will provide a great advantage of observing the solar activities continuously. The spacecraft carries 7 payloads, observe the photosphere, chromosphere, and the outermost using electromagnetic and particle detectors. Using the special vantage point of L1, 4 payloads directly view the Sun and the remaining 3 payloads carry out in suit studies of particles and fields at the Lagrange point L1. The suite of Aditya L1 payloads are expected to provide most crucial information to understand the problems of coronal heating, coronal mass ejection, pre-flare, flare activities and their characteristics, dynamics of space weather, study of propagation of particles and fields in the interplanetary medium, etc. Major science objectives. Understanding the coronal heating and solar wind acceleration. Understanding initiation of coronal mass ejection, CME. place and near Earth space weather, to understand coupling and dynamics of solar atmosphere, to understand solar wind distribution and temperature anisotropy. Lagrange points. Lagrange points of a two-body gravitational system. The Lagrange point are the positions in space where a small object tends to stay if put there. These points in space of a two-body system such as Sun and Earth can be used by spacecraft to remain at these positions with reduced fuel consumption. Technically, at Lagrange point, the gravitational pull of the two large bodies equals the necessary centripetal force required for a small object to move with them. For two-body gravitational systems, there are total 5 Lagrange points denoted as L1, L2, L3, L4, and L5. The Lagrange points for Sun-Earth systems are shown in the figure. The Lagrange point L1 lies between the Sun-Earth line. The distance of L1 from the Earth is approximately 1% of the Earth-Sun distance. The Aditya L1 mission will be launched by ISRO PSLV rocket from the Satish Dhawan Space Center, Sriharikota. Initially, the spacecraft will be placed in the low Earth orbit. Subsequently, the orbit will be made more elliptical, and later the spacecraft will be launched towards the Lagrange point L1 by using onboard propulsion. As the spacecraft travels towards L1, it will exit the Earth's gravitational sphere of influence, SOI. After the exit from SOI, the cruise phase will start, and subsequently the spacecraft will be injected into large hollow orbit around L1. The total travel time from launch to L1 would take about 4 months of Aditya L1. The trajectory of Aditya L1 mission is shown in the figure above. Why study the Sun from space? The Sun emits radiation light in nearly all wavelengths along with various energetic particles and magnetic field. The atmosphere of Earth as well as the magnetic field acts as protective shield and blocks a number of harmful wavelength radiations including particles and fields. As various radiations do not reach the surface of the Earth, the instruments from the Earth will not able to detect such radiation, and solar studies based on these radiations could not be carried out. However, such studies can be carried out by making observations from outside the Earth atmosphere, that is from space. Similarly, to understand how the solar wind particles and magnetic field from the Sun travel through the interplanetary space, measurements are to be performed from a point which is far away from the influence of Earth's magnetic field. Is Aditya L1 a complete mission to study the Sun? The obvious answer is no, which is not only true for Aditya L1 but in general for any space mission. The reason is that due to the limited mass, the power and volume of spacecraft that carries. The scientific payloads in space, only a limited set of instruments with limited capacity can be sent on board the spacecraft. In case of Aditya L1, all the measurements will be made from the Lagrange point L1. As an example, the various phenomena of the Sun are multidirectional, and therefore the directional distribution energy of explosive phenomena will not be possible to study with Aditya L1 alone. Another Lagrange point is known as L5 is a good vantage point for studying the Earth-directed CME events and assessing the space weather. Also, the polar regions of the Sun are not well studied due to technological challenges of achieving spacecraft's orbits for such studies. The Sun polar dynamics and magnetic fields are believed to play an important role in deriving the solar cycles. Further, the polarization measurements of solar radiations at different wavelengths are required to understand the various processes occurring in and around the Sun.